Hello and welcome back to the Oxford MAT Livestream. My name's James and this time we have the past papers from 2010, 2011 and 2012 and so much else going on at the same time. My goodness, good to have you with us if you're joining live. Good to see you. That's a little bit weird, isn't it? Let's try and adjust that. There we go. That's a bit better. Let's see if chat's working. I think we've got chat. It's me in chat at the moment, and Jacob. Brilliant. Okay, there we go. There's chat going as well. If you would like to join chat, that is at slido.com and put in the event code MATLIVE, which spells Mat Live, which is what we're doing. If you're watching this live, then it is very soon going to be the deadline for registering to make an account in the admissions test booking portal. A fun website. That deadline is coming very soon, and the deadline to book a slot at a test centre is also coming up very soon. If you're watching the recording, oh my goodness, please, we've had this at the start of every episode, so I hope this isn't anybody for real, but if you're watching the recording and you're taking the MAT in 2025, then please follow that link to make sure you've made arrangements to take the MAT in 2025. Right, okay. I'm hoping that if I say it every week, then this year we will have 0 people who are caught out by the existence of a deadline. Okay. Hello to A-Post and Anonymous in chat, and Jacob as well. And good. So what have we got? Why does Matt keep asking questions not in the syllabus? That's an interesting question. So we don't ask questions not on the syllabus. I mean, we ask questions that use ideas that we think all applicants know, with a syllabus for the kind of frontier of what we think people know. You're right that you could do a question from last year using modular arithmetic if you wanted to, or you could talk about remainders. And we thought that all applicants to Oxford in 2024 had seen the idea of remainders, so much so that we didn't need to warn them in advance that we know they've seen remainders. And then we wrote a question that used remainders. You were not required to use modular arithmetic to do that question. So it's not even fair, I think, to describe it as a modular arithmetic question. Right, that's my two cents on that one, I think. Right, we're running a poll, I think. I have not launched it. Start the poll, there we go. Which is, how was your day today? Which I like to ask chat as well. As well as them asking me questions, I ask them the questions. But this is the main one that we ask at the start, isn't it? Anonymous in chat is also encouraging people to book, which is good. Hello to Alan and Hugo as well. So people are voting. I'm always keeping an eye out for people who are having a terrible day, just in case the thing that will make their day less terrible is to chat about some MAT questions with me. I've loaded in another 3 past papers, and my plan is to try and do less messing around. I am guilty of some messing around, I know, but I want to get through as many questions as we can. I might have to stop slightly early today, so I'm going to try and make sure that last time I was running out of steam towards the end, and this time I'm going to make sure I run out of steam before the end. No, wait, I'm going to full steam ahead for the whole thing. That's the attitude. Hello to Mary in chat as well. Mary. Right, okay. So next poll, if you're getting ready for another bit of voting in chat, thank you for voting there. People who are here. You voted that you're having an okay day, mostly. Next bit of voting is going to be which question are we looking at. If nobody votes for anything, my pick of multiple choice questions from 2011 might be this one with the F's in, or it might be this one with the integral in, because I think this question is, I have things to say about how you might do that question. I'm sure I can talk about all of the questions. Let's find out what I'm up to. So I hope you're having a good time. How do I recommend preparing and practicing? I'll do the question while I switch on this. No, that's the wrong one. This one. Oh, I didn't actually launch it. Perfect. Start. They've moved some buttons around. I wonder if anyone's noticed. I think I've got away with this. Right? No, of course not. So someone in chat is asking for 1J, which is this. Yeah, I think it's tricky. I'm not certain that it's tricky in a way that I'm not sure it's tricky in a way that I have exciting things to say. I'll scroll out slightly so it's on the screen there next to the voting. There we go. People are voting for it. So far, everyone who's voted has voted for this one. The 3 people, the quick voters. The positive whole numbers is the key thing. It's just sort of quite a weird question. It's about your understanding of how powers work for different real numbers A and B. You might have decaying or growing functions, and then it is an inequality, and it's an inequality that's supposed to hold for just finitely many numbers x and y. So there's quite a lot going on there. There's quite a lot of variables. Is it 5? So I can see why that question is getting a lot of votes. I has also got a few votes as well, so we'll put it on the screen so people can have a look at I while we're voting. This is integral, and then we're also asked to, well, I suppose we're not actually going to integrate this, I hope. I mean, it looks horrible. I remember last week we talked about how do you know what to do first, and maybe first thing I try is integration, and that I try that for about 40 seconds or something, because I go, well, this 4 integrates to 4a, and this 2 to the x squared integrates to I don't know what. It integrates to 4x, and then I plug in a and 0 if I'm being precise, but my point is I have no idea how to integrate the second term. So that's my 40 seconds of can I actually just do this? Sometimes you can. And then the question is going to be, when is the derivative of this with respect to a, which is kind of maybe not the letter you usually differentiate with respect to. And we've got some options, including root 5. And if you weren't here last week, but you are here this week, you might have just noticed that this is an old question where there are only 4 options. Modern MAT questions have 5 options. Good. Okay, as voting, so people in chat, how do I recommend preparing or practicing for interviews? Callie's got some ideas in chat. Callie is a current 3rd-year student, and they're answering some questions in chat. Thank you, Callie, if you're watching. They've recommended, if you've got access to anyone in your school who can help you with a practice interview, alternatively though, just practice talking to your friends about maths, or explain a solution to a math question or something, that sort of thing, because that is an important skill, to explain what you're doing. It's important for mathematicians in general to explain what they're doing rather than just do things. I suppose both are important skills, right? Doing things and explaining them. I've also got something to promote, I suppose, which is that after this live stream reaches after we've done all the past papers, then there's a short break for the actual test to happen. But then a little bit later in the year, I'm running a bonus episode where we will look at some past interview questions that I've been involved with for maths at Oxford. So we'll look at some examples of interview questions, and I'll try to give more detail about what we're trying to achieve in interviews. Or that will be some online experience with one of me and several of you. Good. Okay. There's also a question in chat about whether if you haven't done the questions yet, should I watch this live stream after I've done them, which is my strong recommendation. There is some advantage in joining in live, in the sense that you get to vote. For example, you could be one of the people who's voted for this to be a discussion of J and then I, and then maybe a quick look at G. Probably not H, because I think that's the quick look around. Oh no, maybe H, yes. And not F. Nobody's voted for F, correct? Yes. Oh, brilliant. Actually, nobody's voted for F, which is not on the syllabus anymore. It's the trapezium rule. We don't assume that people know the trapezium rule. Good. Glad that message has got through. Good. I think general advice is you should have a go at the questions first. There's some advantage to being here live, but there is a big advantage, there's a great advantage to having tried the questions yourself before you see somebody else have a go at some of them. So maybe you need to pause the video, or you want to try and get ahead of me by looking at 2011 before I get to 2011, or 2012, which is about an hour and a bit away, or maybe you'd like to join in next week when we'll look at 2013, for example. And there's also a question about like 4-marker questions on this year's maths and whether the difficulty is there or not. And if I'm honest, we are not that concerned about whether the difficulty of the test is the same year on year, because we do no comparison of people's test scores against different years. So maybe not, you're being compared against other people doing MAT in the same year. So if it's the case that you find this year's questions harder, maybe everyone does. That's the kind of sharp end of it, I suppose. It just doesn't matter to us very much if the average is 50 or 55 or 45. It's not the extreme. If it's higher than 55 or lower than 45, then things are slightly harder for us on our end. And of course, everyone has a nicer day if the average on the test is 55 rather than 45 by approximately 10 marks. Anyway, right, what was I doing? I was doing I and J in some order, I think, and then maybe a quick look at G. But also, I think I was doing some messing around, so I think I should stop messing around. Okay, so the question here is trying to work out whether you've got that kind of understanding that I suppose integration is the opposite of differentiation. It's quite a hand-wavy statement. Let me try and justify that quickly. This function, I'm not doing an accurate sketch of it at all, but here's some function which we're integrating from 0 up to a, and you are familiar now, I think, with the idea that when you integrate, that's got something to do with the area underneath the curve and above the x-axis, provided that this function is positive, which we could think about, but go with this. The idea is that if you then differentiate that function with respect to a, you're asking the question, what happens if I change a little bit? So it's helpful to think about this before you go into a test, but you can piece together these ideas about integration representing an area and differentiation from first principles. You can kind of piece those together to work out that by the change in the area, if I change the value of a little bit, is the area of that little rectangle there, which is something to do with how much I changed a and something to do with the value of the function. So differentiation from first principles says, think about, for a very small change, think about the effect of that change and divide by the size of the change that you made. So here the effect of the change is that the area changes by this much, where that's a rectangle of width change, and I'm supposed to divide by the size of the change. So then your idea becomes, aha, if you have integral depending on a, because the upper limit is a, of any function, so if this, then the derivative of I with respect to a is just f of a. It's just the value of the function at that point, the height of this rectangle, because again, area is the thing that we're measuring with this integral, and differentiation says you look at a small change and divide by the size of the change, the dx, if you like. Okay, then we just look at the height of the rectangle. Right. So that gives me some relationship like this. So then if I want this to be 0, I just need, so in this question, once you've had these kind of thoughts, all we need is, we want this. And now we have an equation to solve, so we'll go and solve this. And it's got an x squared in it, so I'm expecting a kind of plus and minus thing here. I notice in the question they say positive, so I think we're going to be fine. And I'm not going to follow through the algebra from there. I think the key thing is this relationship between integration and differentiation, which you've maybe heard somebody say in a hand-wavy sense, that integration is the opposite of differentiation, or differentiation is the opposite of integration. But observation, you can combine together your understanding of differentiation from first principles and your understanding of integration. Okay, it's quite abstract because the function here that's being differentiated is some sort of abstract quantity for how much area is there for different values of a. That is a function, right? You give me a value of a, I would have to go and integrate, and I don't want to, but I go and integrate and calculate the value. There's a unique value for each input a. That's a function. I suppose moral of that is when you see I of a, this is being written as a function of a, which might make you say, hey, what's going on here? Because you need to understand that this is a function. Different values of a give you different numbers. Not a function of x, a function of a. Right. questions in chat. What else chat going on? Chat says, okay, see you next week, which I think is the person who I suggested they should try 2013 and catch us next week. And there's one else about personal statements, which Callie has put a reply to. Lots of maths I've been doing, or is it more important to say what you enjoy? Callie says, talk about both, which is great advice. Thank you, Callie. Someone's just started year 12 and they want top tips. Let's put this on. Oh, no. Top tips for a year 12 student. You're going to learn lots of maths, but you already know lots of maths. You already know lots of things on the maths admissions test. If you want some tricky problems, stuff like this one probably not yet, because you might not have met the idea of differentiation yet, but some of them, like this one, which chat's asked us to look at, something like this one, I think you could do when you're in year 12, or it's really hard. I mean, all of the year 13s who are here pretty much have voted for this to be one of the things that we talk about, so it's not easy, but if you want a bit of a challenge, then you could start looking at some of our test questions, if you like. I'm not saying you have to, I'm just suggesting that might be a fun thing for a year 12 student to do. I have a strange definition of fun. And then Anonymous wants to know about working out paper in the exam. It's not infinite, because nothing in life is infinite, but there is a system for you to request more. It's an exchange system because they don't have infinite resources in the test centre. So you have some working out whiteboard thing, and you can swap it for another one. Okay, so not infinite because you're time limited, but there's no intention that you should only have one or something like that. Okay, right, that's probably enough about whiteboards. Let's talk about finitely positive whole numbers, x and y. And the question is, highlight is finitely and positive and whole. So that's quite a lot of keywords in this question. And we have this inequality. And my first guess of what I want to do when I see a question like this is perhaps to sketch both sides. It's an inequality involving functions. Last week we saw some trigonometric functions where actually that was phrased as an equality. Things were supposed to be equal, but we found out after lots of work, we found out that one of them, if you remember them, they were the functions that looked like this. We found out that one of them was just almost always larger than the other. So the options for equality between those two functions last week, pretty limited. Here we're very interested in, thematically, limited opportunities for the inequality to hold, because we're looking at finitely many positive x and y. Anyway, I'm not getting anywhere with this. I need to draw a picture. So I remember, because it's on the MAT syllabus, a to the x like this, if a is positive. Is that true? No, that's not true if a is greater than 1. A of x like this, if a is less than 1. So I'm already interested that if a is greater than 1, then a to the x has lots of large values, doesn't it? Possibly loads. Can I make this be true? So you see, only finitely many cases. Okay, I need to think about b to the y as well. Do I want to say this stuff about the y-axis? I occasionally get caught out by this, and maybe you do too, so I'm going to say it, which is, if there's x and y in the question, and you're drawing some graphs, you don't have to think about those as the axes. Maybe that's obvious to everyone, I don't know, it catches me out, right? That when I see c times b to the y, part of my brain goes, ooh, a function of y. We should sketch it so that for different y values, you get different, I don't know, maybe they would go sideways if they were large values when you put in y values. And you don't have to have y as your other axis, your vertical axis on the plots. I mean, what I've sketched here is just a to the x. And I might be also interested in b to the y on a kind of separate picture where this is y, changing here. X and y in the question are just numbers. And there are loads of letters in the question, so I could put whatever I like on my axes, or indeed just really have one axis and then the value of a function. guess I'm thinking about left and right separately. I know x and y are different numbers, but I don't have to incorporate them into the same plot, or x and y. I think if you type this into Desmos, which you can't do during the test, but if you are messing around and type this into Desmos, I think it does interpret this as x and y axes. So I think it does that for you. It always thinks that x means sideways and y means up and down. You don't have to. You have options. Right. How am I doing? Am I doing the thing? Am I doing the thing? Yeah, I'm doing the thing. I should stop that interaction. Nobody's talking in chat because I've left the poll on. And it's quite hard to also talk in chat if the poll is on. We voted now, we're doing this. Okay, so observation. Notice that if A is greater than 1 and B is less than 1, then there are loads of solutions. Loads of numbers x, y that work. Observation, if A is greater than 1, then I can make the left-hand side enormous by making x some large number, just any large number, and there are many large numbers out there. And I can make the right-hand side, let's get it right, I can make the right-hand side very small by making y another enormous number. It doesn't have to be the same one, so it's extremely lots of solutions over there. I suppose I should multiply these by c, but still, even if c is big, I can just take x to be extremely large. That'll be okay. So my gut instinct is that if I want finitely many solutions, maybe I want the opposite of that. I've noticed that the 4 cases are 4 different things like this. So maybe I want the opposite. So let's think about a less than 1, where, okay, it starts at a to the 0 is 1, and then goes down like that. That's interesting because, well, it's bounded now, isn't it? We want it to be a large thing for this to be satisfied, but it's 1 or less. What's going on the right-hand side? Well, maybe it's a different decaying thing, but then, would that work? So if they're 2 different decaying things, I suppose I want to know which one's decaying faster. I suppose this one wouldn't go through 1, it would go through C over here, which is kind of interesting because C is just some positive number that might not be a whole number, but that could be lower to start off with. But then the decay could be slower, so that we end up with just finitely many. So I think that kind of works. If I make C a small number, but B, we make this one decay very slowly, then this one will sort of quickly tail off towards 0, and we'll get finitely many solutions. Does that work? But I don't know. Also get finitely many solutions in this case if C is. I think I've said something wrong at some point here because I'm about to conclude that 2 of these answers are true. So in this case, if A is less than 1 and B is greater than 1, then do I get finitely many solutions? I might. If C is a small number, then I'll get the solution x equals 0, y equals 0. Yeah, that's all right. Oh, I see. There are infinitely many solutions. In that first case I looked at, there are infinitely many solutions because I could make y really large and it stays true. I need to make sure that when I make x and y large, the inequality at some point stops being true. Otherwise, I'll get infinitely many solutions. I see. So I need at some point a to the x to not be large. I need it to decay. And I need b to the y to grow. So I need these to cross over at some point, if you like. And not only cross over, that's if x and y are equal, that I think about the crossover. I need to make sure that never, even if y gets really large, that it doesn't get just smaller again. And I need to make sure that if x gets really large, it doesn't become larger again. So I think I do want exactly the opposite case. I think I've talked myself into it now. I want a to be less than 1 and b to be greater than 1. And I get an interesting number of solutions if C is less than 1, but they didn't ask about that. So I thought I want this one to start lower so that I get a few. If it starts higher, then this is just never true in any circumstances. So there's this interesting middle case where the b to the y graph is growing and the a to the x graph is going down, and you get some solutions, but most values of y are out of the question because that value is too big. It's bigger than all of the a to the x values I'm looking at. And most of the x values are out because they make the graph too small. Good. Could we solve this algebraically? Says anonymous. Maybe. I suppose something you could do that I haven't tried at all so far is to try taking logarithms of both sides. I haven't thought about that. Yeah, maybe that's good actually, because if you take logarithms, you have if you take logarithms, you have a much easier problem, don't you? Logarithm is an increasing function. These things are positive, so we have is this thing. Oh, I should put a base on my logarithms. I have an e. Oh, this is much easier, isn't it? Because then once you've had the logarithms idea, the question about whether this inequality is true becomes a question about a straight line with values x and y. So that describes some region of space where, I suppose now I do want to think about x and y, and in that region of space, I think I want a straight line with negative gradient, and then negative gradient is going to tell me something interesting about a and b. Okay, yeah, maybe I should think about it like this. That's nice. Okay, this is the region I care about, right? I want y to be small. So finite cases, provided it's got a negative gradient. If it's got a positive gradient, then I get an infinite region, so I get lots of solutions. Okay, good idea. Thank you for prompting me to think about algebraically. Somebody else says, is it the most efficient way? And I think they mean me trying out lots of cases. I'm not sure it was efficient, but it was quite revealing. It made me think about what the 4 cases are like. And I know that I'm glad I didn't just show you some logarithms, because I know that I like logarithms more than average. So I think if I'd just shown you a pile of logarithms like this, some people would have had a great time, and some people would have said, there goes James doing all his logarithms. 3 thumbs ups for a question that just says, will the multiple choice questions be harder this year? Much harder this year for the later questions. So people are really keen to find out, are the multiple choice questions, which are coming up on a real exam in the future, going to be harder than the ones on the screen? And I think I can't comment for obvious reasons. And I've tried already to convince you that it doesn't matter. That your personal experience might vary depending on how the questions are, but as an admissions test comparing applicants, not so much. Good, okay, right. It's supposed to be reassuring. I think I've said something like your personal experience may vary, which doesn't sound very personal of me, but in some sense it's supposed to be good news. That if you think a question is a real stinker, then there's probably other people do as well. We have, broadly speaking, the same number of people that we need to admit the same number of people more or less as last year. So at the end of the day, there we go. Well, okay, good. Right, let's do something else. Could look backwards. Let's look quickly at these ones. So G got quite a lot of votes, and I think H was in there a little bit as well. This is a functional equation, which you don't have to know those words. I'm just trying to say there's an equation with functions in. It's got some rules. It's got some rules about what happens if you double the number going in, or what happens if you double the number plus 1. There's another example of this in a later year, so we'll see later in the live stream a different example. But this is a case where I feel like you can just check small numbers if you want to. You can think about how, as you apply these rules to work out, for example, you can work out f of 2, because I've doubled the number, it says 2 times f of n. Or I could double the number and add 1, which would inform me that f of 3 is 4 times f of n. As you make this tree, you realise, I think, that your options are to multiply by 2 or 4 each time. That's what the rules say that you might do. And it's slightly tricky to work out what these things are as you're going. So doubling gives you f of 4, or doubling an add 1 is f of 5. But it is okay to count the number of branches in this tree which end at 16. So 16 could be made of 2 4s or 4 2s. That's a good example of a number where I can mix those things around. 4 2s going this way down a sort of tree structure. The question doesn't say what are the numbers n, it just says how many. Made of 4 2s over there. It's made of 2 4s going this way. So this will be f of over here. 2n plus 1 is 7. Aha, good. See, for example, that one's 16 because I multiply by 4 again using this second rule. Whereas going this way, I get f of 6, and I'm not done yet. Is 8. And then so I might be interested in going one more step over here. So the question is just maybe working systematically like this, can you work out how many of these there are? And you maybe should go through and check that they're all different. Maybe if you've got experience with decimal number systems that you've thought about, or binary number systems, maybe you know that these are going to be different, but maybe you know, maybe you assume, maybe you check. There are different ways to build 16 using 2s and 4s. Order seems to matter. So 4 2 gave me a different thing than 4 2, 5 or 6 inside the brackets. So the question is, how many ways are there to make 16? Which is an easier question than trying to work out when it happens, which is harder. Although if anybody in chat has got a suggestion for what's going on here, what is this function, what's it doing? Not in the question, right? Not supposed to understand what is this function or what is it doing, I think. If you can understand what it's doing, then well done. You could let me know if you like. What other papers, except for MAT, would you recommend for practice? I also recommend looking at, if you like, things like TMUA, which is another maths test. It's all multiple choice. So if you want to see more multiple choice questions, you can look over there. It's got a similar syllabus to MAT. You might also look at STEP, which is all not multiple choice. So if you want other experience of looking at questions that are not multiple choice, MAT's got both, then you might look at STEP. That has quite a different syllabus from the MAT, so some of the questions involve completely different sorts of maths. I also, if you can get hold of it, AEA has got some tricky maths questions on it, so things like that, if you want to look at other maths exams of similar nature. There is a large question bank. What is someone talking about here? It's your last year. Wow, okay, right, great. Do you have a background in computer science? No. Which is like powers of 2. I think they need me. If I enter the MAT this year and do okay, since I'm in year 12 and comfortable. If you enter the MAT this year and you're not applying to Oxford, then I'm afraid your application will be cancelled and you will not take the MAT. The MAT is only for people who are applying to Oxford. Sorry, that's quite strictly enforced, I'm afraid. So rest of content is it's one of those if statements where the if is false, I'm afraid. If somehow you have taken the MAT in 2 years, then it's only the MAT score that you took for applying this year. Assuming that you're applying, let me say that again because you're year 12 and I forgot. It's only the MAT score that you for the current admissions round that matters at the point where an admissions decision is being made. We don't look back at previous MAT scores. I got there in the end. I feel like I should have another go. If people are reapplying to Oxford, then we don't look back at their past MAT scores and we don't connect their applications at all. So if somebody applied back in the day and also applied this year, I'm probably not even going to notice. What is the view on resit and reapplicants? I'm talking to chat, let's put chat on screen. We'll do a long question in a second, but we're making good progress, I think. What's the review on resit and reapplicants? You're allowed to reapply. You are recommended to apply to a different college so that your application is seen, to start off with at least, by a different set of tutors. I think you'd be treated fairly wherever you apply to, but it's for your peace of mind that if you reapply, that you know that you're being looked at in the first instance by different tutors than the ones who saw you last year. And you're in open competition with the rest of the applicants. And then the other half of the question says, what about resits, which is kind of totally different, right? Resit is when things. So resit would be for like your A levels or something if they didn't go to plan, but you might be resitting them. And the rule on UCAS is that you declare all your full qualifications. So you might have a plan to retake exams so that you can get the grades that Oxford was looking for, but usually Oxford candidates are not resitting exams. We are allowed to base admissions decisions based on previous academic grades. So I never say never. Shouldn't say never. I've been doing this for years and I've seen everything happen, I think. But yeah, and I'm being very general, but because some people I know are doing resits for a reason, that they're doing resits because of extenuating circumstances, or because they had to drop out of exams, or because something terrible happened during their A levels. Yeah. But on the other hand, if you're taking a gap year because your A levels didn't go to plan, then you're welcome to apply to Oxford. Right. Okay. What am I doing? I'm doing a long question next, I think. With this kind of cascading thing, I thought about maybe thinking about this. You should graph this. I don't know. I bet you can do it algebraically. There's a person in chat who suggested a moment ago that I try things algebraically. I think you should do a graph of this. There's a polynomial on the left-hand side. You know loads of things about polynomials. You know where all the roots are for the polynomial. They're at the numbers 1, 2, 3, 4, 5, 6, n, right? So you know where the roots are. You know it's probably some wiggly polynomial shape in between. Wiggle, wiggle, wiggle. And you asked various things, aren't you? The equation has at least one real solution x. Does that sound true? Maybe. I mean, you know, it's 0 at some places, and I know when x is really large, once it's stopped wiggling around through all of these zeros, and it's going off to positive infinity. I don't know what happens when x is very negative, because even odd seems to matter, maybe? And if I've got an odd number of terms, then I think it goes down. So maybe it goes down, maybe it goes up. Question mark. But yeah, okay, if k is greater than 0, I do expect to get a real solution kind of over here somewhere. You know, that sort of thing, right? Thinking about the graph and thinking about the shape of this thing, it's much easier to convince yourself that there is a root, is a solution over here somewhere for some value of equals k, this high. How high? That high. It's much easier to convince yourself that there is such value rather than actually trying to solve for it or trying to find out where it is. There's a huge polynomial on the screen. Someone's asked my favourite. Oh, that's such a good way of wording that question. That is such a good way of wording that question. How trustworthy is Oxford personal statement advice online? I've seen lots out there, but not sure what I can rely on. Please can I quickly describe an effect? There is an effect that everyone who is at university, that's not true. There's an effect that lots of people who are at university believe that they know why, or believe that they must have some insight into what it was about personal statements or what shoelaces they were wearing on the day of the exams or something. There's lots of people who have advice which varies wildly, from advice that I think sounds quite plausible to advice that I think is not lining up with how university admissions works. There's a huge range out there, as I think you've noticed. Lots of students are now very keen to share. I think that's probably good, that lots of students are demystifying things and sharing things. Where students start to try and guess admissions things, I guess undergraduate students are almost never involved in Oxford admissions behind the scenes. So other than attending some interviews and having written one personal statement, most students have got no experience of the other side. So while they might have an opinion that their personal statement was fantastic, you don't have to believe them. Right, okay. There was a bit that I've been thinking about quite a lot recently. It's not any current students in particular. If you're watching, you're all great. Some of you have got really great personal statements, haven't you? Right, okay. Do I know what the reusable notebooks are like? I think they vary a little bit. The advice I've been given is that they're either laminated paper or spiral bound whiteboard something. I don't think I've seen the spiral bound whiteboard thing, but I've had a go with the laminated paper whiteboard things. It wasn't wasn't as bad as I feared. So there's some stuff going on there. It's extremely unlikely that a resit candidate will get an offer. Yes, in the sense that without any other information, all of the information in that question is candidate, which means someone applying, and we have lots of applicants, and then resit, which means that their recent experience of doing an A-level didn't get the grade that we look for. You have way more information than me, right? I'm not doing a personal evaluation on you. I'm just saying that if all of the information I get is you're a candidate, then already we're oversubscribed. And then you say resit, and already you're the only information I've got is that an A-level didn't go well. If it was maths or further maths, then there are other candidates who are really, really good at those A-levels. You have more information than me. I'm not going to try and evaluate your application now, of course, because, well, partly because I've got a job to do, and partly because there's like 40 other people watching live, so that feels weird. Let's talk about a long math question instead. Oh, right, so exactly, it's extenuating circumstances is what I mean. If you've got more information, you can declare that on your UCAS application, either by talking about it in personal statement or by getting your UCAS referee to talk about it in the box labelled extenuating circumstances on the UCAS reference. There's a whole box. Or you could, if in doubt, contact the Oxford College that you're applying to. You see, if all the information I get is my A-level maths isn't the grade that you're looking for, then it's really hard. Good. Okay. Basic properties of circles. Around, aren't they? Basic properties of circles. So we did a MAT live stream a few weeks ago, just before the start of the summer, where I tried to answer that question about what do we mean by basic properties of circles. I think that the area of a circle, the area of I'm going to get all the words wrong, aren't I, because I haven't rehearsed this. The area of a region of a circle, like a slice of pizza, subtended by an angle theta. So you know, theta at the middle, how much of the circle is that, like a pie chart. You should know how to do that area, and you should also know how to work out the arc length around the outside for that kind of pizza diagram that we're both thinking about. You should know that tangent is at right angles to normal for any point on the circle, and you should know that the angle in the semicircle is a right angle. I can do a few more of these. Are we doing? We're voting for 2. I want to talk about 2, or the vote's currently for 2. I can do a few more circle things while we're here. But if you want to get ideas that are not just off the top of my head, then a good place to look is on the MAT Livestream website. If you go to, I think it's the geometry episode, you don't have to watch the YouTube video. You can just get the worksheet, which starts with some revision notes, where we go through in more detail what basic property of circle means, with some like facts and some practice questions, and then in there are some MAT questions on related topics, so only a few. Circle theorems, there's a couple more that people know. So angle subtended by a chord is, I think, quite a good one. I think we've got a question coming up that uses angle subtended by a chord. There's one in the thumbnail that's a bit like that. Not a lot of stuff. Enough that you could, I think in an afternoon, you could browse through the worksheet, maybe look some things up a little bit, get them all in your head. One afternoon? It's almost the weekend. People are voting for 2, and I am in my new getting on with it phase, although I don't think I've got the timing right if it really is a getting on with it phase. Let's just do this. Thank you, chat. 5 was pretty close there as well. Okay, right. I have a point to make about this question. I hope people like it when I make a point about a thing. I hope it doesn't just sound like me ranting about something or going off on one unsolicited, but you know, I can do the questions, but also, yeah, for this one at the front, where we have this implausible looking equation where perhaps you know that square root 2 and square root 3 are irrational numbers, and if you don't know that, there's a hint here as well, which tells you in square brackets you may assume that root 2 and root 3 are irrational numbers, which cannot be written in the form p over q, where p and q are integers. Because people know that, I think people get the sense that this equation just looks implausible, and then people really want to tell me that A is 0, B is 0, and C is 0. Ideally without doing very much work, which it then is bad, because the whole point of this question is about the work. It's about the explanation in the middle. So for example, just saying comparing coefficients is not enough. You haven't really engaged with the question if you just say comparing coefficients. The point of the question is to demonstrate why that's true. The question actually tells you to do this, right? Because it says by squaring both sides of the equation. So that's a direct instruction, and if you don't follow it, then you might not get the marks. This is a show that question where there aren't marks for getting this fact. It's printed in front of you. So if you copy out this fact, you don't get a mark for copying it out. So it's all about the explanation in the middle, where we need to do something to essentially justify why we can compare coefficients. So there's some stuff going on in there. Okay, explainy questions. Yeah, that's a good request in chat. I'm going to make a note. Explainy questions. Okay, I've hidden chat on screen, but I still have it on my second monitor so that I can see if, especially if people are, if I do something stupid, if people can let me know. Right, okay. So what I'm hoping that people do for this is to demonstrate why we need to have all of these coefficients equal to 0. The question tells us to square both sides. Let's bring this over here. I'm going to zoom out a little bit so I get the question and a bit of working space. I don't know. I only get this like poxy little margin. I wish I had a whiteboard to do things on that you could also see. So this. So I'm going to put suppose on the front. Then I would have 2a squared plus 2 root 2ab plus b squared equals 3c squared. And why is that a problem? We're trying to show that this is a problem. We're trying to show that these things are all 0. Quick think, if they are all 0, does that work? Yes, but that's not convincing because we're trying to check there aren't any other solutions. If you want to think about this as an equation with solutions that follow on, we're trying to work out that there aren't any others. No alternatives, only 0. Right. So I think this looks suspicious to me because of the root 2 in here. Well, I've got to consider that maybe once you've done all this multiplying and adding, maybe you end up with 3c squared. That seems unlikely to me, but we can make it more precise by saying, because it could be true. We have to be careful here. Like, if your proof, as you read it, just convinces me that this is impossible, well, that's not right, because it is possible. A could be 0, B could be 0, C could be 0. So I think what we want to say is, well, let's do this in slow motion. 3c squared minus 2a squared minus b squared. I'm trying to get this root 2 on its own to really look at what's going on here. So then if ab is non-zero, then we can divide by it. We have root 2 is 3c squared minus 2a squared minus b squared over 2 root 2. And I'm doing this over ab. 2ab. That's unlucky. Over 2ab. I'm doing this in slow motion, not slow enough apparently. I'm doing this in slow motion to demonstrate that at each stage of this, it's really tempting to just say comparing coefficients, right? There's this thing with root 2, like, come on, that's not going to happen, is it? There's a thing that, yeah, but really the point of this question is to sort of work through all of it and use these facts to talk about these things being irrational. This demonstrates that root 2 would be this combination like this, but then it would be rational. But root 2 is irrational. What we would have done here is write it as a ratio, which is not okay. Yeah, okay, there's an alternative suggestion in chat, which I'm going to do in a second, I think. So I've got this kind of contradiction that I suppose, suppose this. And I'm also supposing that AB is non-zero. Then I get down to this expression, problem, root 2 isn't irrational. Root 2 isn't rational. So either we're done, or AB equals 0. Because we had these two things that we supposed, right? We supposed this, and then we said if. Because I've written out the words, I can see where I'm doing the supposing. I do recommend scattering some little words in, partly to make sure that people reading stuff know what's going on, and partly so that you know what you were doing if you have to look back at it. And here I'm mostly talking about when you're at university doing maths or joint honours or computer science. Just scattering a few words in amongst all of your working out is really good for you. Really helps. Anyway, if AB is 0, okay, so then two cases, either A is 0 or B is 0. And then if you follow through these cases, you find you get simpler equations. It's not so bad, and there's a different thing that you can write as, on the one hand, a fraction, and on the other hand, on the other side of the equation, some irrational number. We've used this fact. We have not used this fact or this fact yet. Those are the two cases left over. Yeah, so it could be, so far, by the way, yes, you're right. So far we've got either A equals 0 or B equals 0, and we must complete the proof to work out that in fact both of them are 0. So in either case, I love arrows, in either case, branching off A is 0 or B is 0, in either case you end up with, on the left, discovering that both B and C are 0, and on the right, discovering that both A and C are 0. So you look, oh right, okay. I had two cases, but in both of them, they go round and join back up again around the end. Okay. Yeah, so this means that all three. This does mean that all three are 0, and let's do one of them then. So if A is 0, for example, then we have B is C root 3. So if C is non-zero, B over C is root 3. No, not that. So C equals 0 down here, and then we've got right down here, so I discovered that C is 0 first, and then I have B equals, and I've eliminated all the other terms, so then I have B equals 0 down here from the equation. And similarly in this column over here behind my camera, would be some more maths that does something pretty similar but involving root 2 over 3 instead. You discover that the thing you wanted to divide by is actually 0. I'm being really careful about dividing by 0. Okay, so it ends up at the end. At the end, it all comes out in the wash to say, so maybe A is 0, and then later C and B are both 0, or the other way around. And then, okay, so there's a chat thing. Somebody said a while back, could you make the comparing coefficients argument after squaring? So we are here. After squaring, by claiming that integers squared must be integers, so 2 root 2 times integers equals 0. Almost, I suppose. If you make the claim that, I think you need the fact that 2 root 2 AB is also irrational, because A and B are integers. Unless A equals 0 or B equals 0. So there's a subtlety there. I know that you're trying to point at a contradiction, but you're right that these things square to integers, but this could be an integer as well. It could be 0. So there's this kind of special case that we mustn't miss the special case, because that is where we are trying to get to. We don't get any marks if we just write it down, but we also don't get any marks if we get to a different conclusion. So, well, we might get some marks for working out, but hey. Okay, so I think this is a thing that differentiates candidates a little bit. The sort of almost missing the point of what the exercise is trying to do, or not following instructions in the question and just trying to jump to a conclusion. Something I've seen as well, by the way, is that you could square this again. I'm not sure you should, but you could square this. It's got a root 2 in it. Let's try squaring it and see what happens. And I think that might end up being a proof that the square root of 2 is irrational, buried inside a proof of this fact, but there we go. Okay, so we get to use this fact later on, because after you've done a little bit of geometry, to tell me about distances. So in here, you get to use that fact to tell me that, well, you've got some complicated geometry expression. And your complicated geometry expression is of that format at the top. You have now got strong feelings about what A, B, and C are in terms of your geometry problem. You know, it's all distances and points and things being equal and Pythagoras, it's great. But you get to use the facts now. So we proved it in part 1, and now we're using it in part 2. The punchline becomes that small m is big M and small n is big N. So we need to match things up. And that comes from the idea that these coefficients, which come from your geometry problem, must be 0. I like it when this happens in a question. You get to prove something and then you get to use it. And often there's that kind of change of topic or something where at the start it's algebra and then it's geometry, but you're expecting a link, probably. I mean, it's got root 2 and root 3 in it, so I'm expecting that this has got something to do with the previous parts. And then it changes again and talks about a circle and a counting problem. And it tries to distract you a little bit by talking about this multiple of 4 like symmetry thing, where because you're centered on 1/2, you gain these 4 points first, and then whenever you gain some points, like these two, you also gain points over here and here and here. You gain them in multiples of 4, because every point comes with a mirror image the other way, and a mirror image, otherwise known as a rotation, around the other side. So this particular point comes with a mirror image, and there, in a kind of team of 4. You can write that out, I think, just by talking about some particular point X and give it a name. Right, but after that kind of brief distraction, you were asked to explain why, and this is the end of the question. For every k, there is a radius such that the circle centered at root 2, root 3 includes exactly k points. And to read that out, I've combined together my understanding, skimming my eyes up and down the page, with what n means, including what a and b are. There's a circle, and I said exactly for this bit because I've got a feeling that that's important. For any k, right? So it's not just you want at least that many points or most that many points or something, you want exactly that many. I think I was expecting them to say at least k, because then the answer would be you make the circle really big, and whatever k was, if I make the circle big enough, then I get enough points inside. That's not the correct answer to this question because it's an equal sign, which surprised me. Anyway, so not always a multiple of 4, I suppose. And there's got to be a link, right? Because this was talking about the distance from the point to root 2, root 3. You had a punchline. So you proved a thing in part 2, and now you get to use it in part 4 to tell me that these points never occur in a pair of equal distance from root 2, root 3. That as you grow this circle out, you only gain 1 point at a time. Sometimes I try and say things in different words in my head, or when I'm talking on the stream here, say them out loud in different words, because I'm trying to turn around different ways to explain what's going on. I think that's my best advice for the explainy questions. For the person in chat who asked about explaining question 5 and 6 sort of style questions, I think what I've learned to do is try not to get too wedded to my first way of thinking about the problem, to try and have some kind of flexibility, to say, well, maybe I'm thinking about these as being a circle that's growing with radius r, or maybe I'm thinking about a particular moment where 2 points are at the same distance, because I might be about to do some sort of proof by contradiction where I say, suppose there were 2 at the same distance. Or maybe I'm thinking about some fixed number k and trying to solve for r, and thinking about some sort of function of r that goes up in steps, to try and flex around how I'm thinking about the problem. What are the kind of words that I'm adding in about growing, or functions, or steps, or equal distance, words that are not in part 4 of the question. And then once I found some I like, to try and explore thinking about it like that, can I tell a coherent story to myself? I like turning things around a bit. Yeah, root 2 and root 3 are irrational. That's true, but not enough not enough insight to tell me we're done, I would like you to successfully refer back to previous things that you've done in the question. You are correct that whenever those two numbers are irrational, provided that their ratio is also irrational, provided the ratio is also irrational, then you get a fact like this. I think that's true. Yes. Proof. Redo part 1 with different numbers. Good. Okay. Yeah. So on a long question like this, there's actually very little maths. What maths are we actually doing here? Like we have to square some quantities. You can get GCSE students to square quantities for you if you need to. Like in the real world, if you need to square something, like you could just do it, or you could ask a GCSE student to do it. If you can find any around. So the actual maths that you're doing here is not really the exciting part. I think this question might be close to 100% ideas based. So the idea of dividing by this to talk about root 2 is much more interesting than whether you can successfully write 2ab in the denominator. And that took me 3 attempts, so lucky me. The idea of how to do this is way more interesting than the algebraic manipulation for this particular question. Right, good. That was a question, how many of the marks come from explaining yourself and how many from maths? It depends by the question. We've definitely had questions which are very sort of algebraically heavy, where people were getting quite a lot of marks for doing quite a lot of algebra, but we also have questions a bit like this, and it's really hard to tell when you look at the question, and it doesn't really matter. But in terms of your strategy is still to do the question, right? So you should have a go. This year, because people are typing their answers to the question, you should not expect algebraically heavy questions, because people can't type algebra on a standard keyboard. Maybe don't tell me, maybe I can look at chat, maybe you've learned how to do algebra on a standard keyboard, good for you, but most people haven't. So you should not expect those long questions with the typing to involve algebraic stuff, because that would be a nightmare to type. Instead, you should probably expect to explain your answers. Right, good. It's 6 o'clock. I'm going to look away from the screens just quickly. And this cup of tea is going quite cold, so I think I'm going to... I don't like to give up on a cup of tea though. This is a break for you as well. Time to perhaps look away from the screen briefly, because we've hit 6 o'clock. We've only done one paper, we've only done one question from one paper and some short questions. So I'm going to try and accelerate a bit, especially because dinner is slightly earlier for me today, so I'm trying to get away nice and promptly so I can get to dinner on time. It's not a great reason, is it? But here we are. What would a great reason be? A great reason for leaving a live stream promptly? Oh well. Mark ratio of short to long. This year it is 70 to 30. There are 70 marks for short questions and 30 marks for long questions. There's a mix of 2 mark, 3 mark and 4 mark short questions. That is all labelled on the question, and those long questions are each 15 marks, and the parts break down how many marks there are for each part. Cool. Can you get full marks if you arrive at the same conclusion but with different reason of the mark scheme? Yes, provided that you follow instructions in the question and that your method works. Evened out, if you're looking back at the mark scheme or something, and actually it's not a mark scheme, it's a worked solution, but let's not go there. If you're looking at the worked solutions on the website, then it's often the case that you might have done things slightly differently, or even quite differently. If you've done things very differently and it feels much easier the way that you've done it, then, well, double check your work. And if that's the case, then maybe email me, because maybe I should do something with the worked solution if it's unnecessarily difficult. I do like to know if my maths is unnecessarily difficult. Speaking of, let's look at question 1J. I think people are going to vote for J anyway. Let's look at 1J from where are we now? 2011? 2011. If you do all your working out on a whiteboard, how do they know how many marks you should get? Sorry, so when I was talking about working out, I was primarily thinking about the question that was on screen, which was from a long time ago when the test was done on paper. And then for working out, people on the long questions this year in 2025 are going to type some explanations or type some justifications, type in effect they're working for that question into a box. But I was trying to encourage that person that they should not expect to be typing out algebra or something like that, like reams of fractions or something. Like, how would you even do that? Okay. So you don't get marks for working out on multiple choice questions, and you do get marks for partial solutions on long questions, which might include work towards the correct answer. Why is 2019 and 2015 so difficult? We just do that sometimes. I'd be overstating it if I said it was intentional. It just happens, right? You're right. You write a test every year. Some of them are going to be harder than others. 2019 was partly my fault. I think I wrote a question that was slightly too hard and that brought the average down. Or was that 2018? Maybe that was 2018. I think at 2018, I think I brought the average down. I tried to quantify it one time. I think I had some effect on the average mark by. I think there was a question that was a bit too hard, and because everyone had to do it, it was one of the multiple choice questions back in the day. And never mind, let's not go there. Right, okay. Here is a question that I think you might vote for. I don't know. Maybe you'd vote for this one. Let's find out. It's a multiple choice question from 2011, and it's about a function defined for positive integers n. We had a quick look at one of these in the first half. Here's another one. We are told that f of 1 is 1, f of 2n is f of n. Okay, so it's equal like that. And f of 2n plus 1, so it already tells me that, for example, f of 2 is 1, f of 4 is 1, f of 8 is 1. It says doubling very slowly. F of 2n plus 1 is f of n squared minus 2. So that tells me that, for example, f of 3, which I work out by putting in n equals 1, is f of 1 squared minus 2, which is 1 minus 2 is minus 1. And then maybe I can work out f of 5. Can I work out f of 5 if I put in n equals 2? Yes, because I know f of 2. I get minus 1. Can I work out f of... Can I work out f of 6? Yes, because I double... What do? It's equal to, it's no doubling, it's equal to f of 3, but also minus 1. So that's kind of weird. This says that so far, what have I got? I've got 1 on the powers of 2, and so far I've got minus 1 for other numbers, and I haven't got anything else. So suspicions about this function. This is an example of a question where messing around with it a bit to find out what's going on is quite good for you. When you say we have a whiteboard in the exam centre, does that mean we have to rub out all the working out first? No, you don't have to erase anything in the whiteboard. The system is that you get given a blank whiteboard or spiral bound notebook or laminated paper. You get something to write on that's blank, you write on it and you can request a swap. So at some point you've exhausted, as you've moved on to other questions, you've run out of space on the whatever they've given you, you can request us to swap it for a blank one. So you don't have to erase anything. You don't have to spend any time erasing stuff. Yes, so I picked matching questions, Jacob. Yes, good. Okay. So what am I thinking at the moment? I'm thinking, well, f of these powers of 2 is 1. I'm only going up to 100. Those are the only ones I care about. 8, 4, 2, 1. And so far, other numbers are returning minus 1. Is that always going to happen? This is a question that, when you first read the question, that is nowhere near things on my mind. Is it mostly minus 1? That's never been the right answer for a question that I've looked at before. Oh, it's mostly minus 1. No one ever says that. But so far I've only got minus 1s. And if I keep going, then I get things like, well, what's f of 7? So if I'm looking at an odd number in here, then I get a smaller number inside, don't I? Which I suppose, if up to then I've only seen 1s and minus 1s, then this thing in here, if this is 1 or minus 1, then when I square it, I don't actually care which one it was. I don't actually care which one it was. If it was just 1 or minus 1, it'll square to 1, and then we subtract 2, so we get minus 1. So if you use this rule on 1 or minus 1 inside the bracket there, you're definitely going to get minus 1. So that makes me think that if up to a certain point you've only seen ones and minus ones, and then it's time to work out some new numbers, I think the rule on the right always gives you -1. Oh, and then for the even numbers, if it's twice an odd number, then you've used this rule to get f of the odd number, and then doubled, you get 2 times an odd number, but it's still -1. So for 14, for example, twice an odd number is also -1. And right, if it's 4 times an odd number, then you get this, or so on. You get -1s forever. The multiplying by 2 doesn't fix things. Multiplying n by 2 doesn't fix the value, it doesn't correct the value, doesn't change the value, it stays at -1. We're trying different words, right? Fix felt bad because it's staying still at -1, so it feels constant. So change it. It doesn't change the value. It stays at -1, doesn't it? So in fact, the only way you could get +1 from this is to be in this perfect sequence. This sequence that always gives 1 by just doubling n and keeping f the same. And then as soon as you start looking at this rule, you'll get -1. Okay, so I get 1, 2, 3, 4, 5, 6, 7. 7 +1s, and I get, I think, 93 -1s from all the other numbers. That's my guess. Is it a guess? It's better than a guess, isn't it? Which I think is -86. So sort of totally mad outcome that this function is 1 on the powers of 2 and -1 for all other numbers, which I wouldn't have guessed at all going in, because fn squared -2, well, it could be anything in theory, right? And this is an example that occasionally a question looks really, really complicated and has been listed. J is where we used to put the hardest question that we had for multiple choice, or what we thought was the hardest question for multiple choice. It can look really impossible, but there might be something not so bad going on under the hood, behind the scenes, inside the question, once you get into it. Other things. Question number G. Somebody in chat says, is it normal for my MAT booking, saying that my UCAS ID is pending verification? From previous experience last year, that does sound normal, but I would like to check with the 30 or so people in chat. Is that normal for other people? Have other people got this notification? If there's other people, then I'm going to be very relaxed about this. I think that we can't verify. Can I remember the process live? Okay, there's a good caveat, right? Can I remember the process? I think the process might be that we can't verify UCAS IDs until people have applied, until the UCAS deadline, perhaps, until we've got all the applications, maybe. So I think we're not verifying them, perhaps, until applications have all settled. I think we haven't verified anyone's yet. Someone says yes for the question, is it normal, which is very useful. That's not sarcastic, that's what I wanted. I'm going to go with that. I think that's normal, and I think I've worked out why. And somebody else says, where do I check? Maybe you can talk about, maybe work together. Work together in the Slido chat. I've hidden it from the screen. Don't share personal information. Right, good. Okay. Let's do a long question instead. I feel like we need a long question, don't we? So I'm going to reset this. How do I do this? They've moved all the buttons. They've moved all the buttons. Can I just start it and then reset? No. If I start it, then it's got the votes from before. Stop. So smooth. Reset poll. Can I expand this? I can do this. Oh, if you've just joined us, I said at the start I'd do less messing around, and then I've done exactly as much messing around, maybe even more. We're voting again, I think. Chat's helping. If you've just joined, we're in the middle one. We're on 2011, and we're going to do a long question quite quickly, get some thoughts on a long question, and then move to 2012 quite soon. So we're going to do a quick bit of 2011 in the middle here. It sounds a bit like everyone says, I think everyone has got UCAS verification pending, or whatever the message is, which is reassuring. Okay. Do I have any tips for checking our reasoning is sound for long questions? I think if you can, there are two of them, right? So you could do the other one and come back. And coming back to it and reading, not reading what's on your whiteboard or thinking too much about what's in your head, but reading literally what you've written and deciding if this is all that the marker gets to see, is the bit that you've written in the box. Is this enough to communicate the ideas that I've had for this question? That's quite a high bar, really, I think, because maybe you've thought several things and you've chosen this way of saying things. But I think, if possible, switch to something else and then switch back and think, I haven't said any of this. I haven't quite said this bit I was thinking about in the middle. Occasionally people type really short answers. I think there's a time thing going on. Occasionally people put really short answers, and I just wish that they'd sort of added a sentence or something, or communicated, because we had this when it was on paper as well, that people would just give us like a little scrap and then you think, oh, put some words. Are you saying this is true? Are you saying you hope this is true? Are you saying not this? Probably not the last one. Okay. Right. Yeah. Somebody on the screen. Somebody's identified a quotient ring. There is voting for questions 3 and 4. Thank you, chat. Not 2, which is fair enough. Oh, look, Fibonacci numbers. What a nice question. So good. 3 is this one about polynomials. It's currently tied with question 4. I'm going to think about which one I want to do. I think 4 is a little bit easier. 4 is about minimizing with geometry. The idea of this question is you think about the graphs and you think about the way that these values increasing give you equals when x plus y is 1, when x plus y is 3 over 2, how far can you push this? Answer, you can push this until you get to that point. And you should use the fact that the tangent is at right angles to the normal, perhaps, to think about tangent, normal, what are the gradients, where's that point? It's not that bad, is it? It's right in the middle. So it's straight lines. And then same thing, but with curves on the right hand side. So we've got xy, and the largest value of x squared plus y squared plus 4xy. I think we can do that just by making x and y very large. So there's a difference between these two on the screen. It's very small, isn't it? Difference between these two to say xy. Should we make that very large, or when it's got a minus sign on, should we make it very small? I think we need to think about both possibilities, perhaps. There's a tension here between making x squared plus y squared large versus making xy large. Would you like to? Maybe this is not true, so I don't think I can get away with this. But maybe this is usually negative, in which case just making the thing 0 would be a large value compared to all of these negative numbers. Right? If I put 1, 1, then oh my goodness, this is -6 over here. I get -4 for my answer. I don't want that. I'm not allowed to put in 1, 1 because of the circle. Anyway, you get my point, I think. Sometimes it's negative, so we should be careful. What do I actually want to do though? So can we do that better? So maybe I do want to sketch things. So the combat there. If we're not in, yes, I suppose the realization is, do I want to be on the outside of the circle? Because I was on the outside of the circle for the previous cases, previous parts of the question, and then I have things like this XY version here, where if I'm not on the outside of the circle, then I might as well be. If I'm not on the outside of the circle, if I'm on some curve like this, then I can move to the outside of the circle, and that makes xy just the same, and it makes x squared plus y squared larger. So I think I should move to the outside of the circle. Okay, that's much nicer. So then I'm just thinking about what's going on around the outside of this circle. The trick there that I'm using is the idea about keeping xy constant, because that's the thing that they're setting up in the question. They're setting up this idea that you should think about xy being different constants. The kind of curves like this, or whatever they're like. They're setting up that idea, and I'm also thinking about it because thinking about xy is quite hard. Thinking about the way it changes as you change x and y, oh my goodness, because it's multiplication, so you're making x larger or y larger, which is more important, which is better if I'm constrained by, oh my goodness, it's impossible. But if I just think about the line where xy is constant, then I don't have to worry about it, because I know that along this line, if I move my point somewhere along this line, well, xy is going to stay the same. So relax. That minus 6xy, that's logged in now. If that's the curve xy equals 1/4 or something, then well, you know, that's a minus 3/2 on the end. You're going to struggle to come back from that, but you know, there we go. So it's fixed in now along that curve. So let's talk about x squared plus y squared as I move along that curve. X squared plus y squared is much easier for me to visualize because it's distance squared from the origin. So for me, I've kind of got these opinions about different things in the question, right? X, Y, I don't know how to maximize that unless I really think. Get off the axes, I suppose, where it's 0. X squared plus y squared, I've got this strong feeling that it's related to the constraint as well. But the constraint by being this thing that we have to be inside this quarter disk where x squared plus y squared just has a nice bound on it. So that's good. That one feels nice, feels familiar. The other one's much harder. Okay. Oh, almost switched that off. Let's switch that off instead. Yeah, so drawing these would not be possible online because you were typing answers with a keyboard. We can still do graph-based questions for multiple choice, of course, where we could do a question where you select a graph. So like this question, which asks you to choose a graph. So you might find that you're doing some graph stuff anyway, but in the multiple choice section. But you can't draw a graph using a standard keyboard. Now, looking at chat, I know someone's going to tell me they've worked out how to draw a graph using a standard keyboard, but not everyone has. So I'm not really assuming they're going to do that. And we also have the opposite question, which is, my map booking doesn't say UCAS ID is pending, should I be worried? I don't think you should be worried. I think you're probably fine. Does it say does it say UCAS ID is not pending or something? UCAS ID verified? Because that would undermine my argument, but I think I'm still happy with the way it's gone for everyone else. Okay, let's look at 3. I think have we talked about this? We have talked about this. Chat, we've talked about this one. Isn't this on the geometry worksheet? I think it's on the geometry worksheet. I modified it very slightly for the geometry worksheet because this doesn't have, it has a diagram dependency, I think, where you need to be told that B is less than A. I'm really sorry if people have put this on here because they're confused by the different cases in part 2. No, wait, the different cases in part 3. I would just ignore that part. I think it should have more inequalities in the question to make it a bit clearer about what's going on. I've tried to add them in the version that we did for the geometry worksheet before summer. You're welcome to go back and look at that if you like. And the number 27/4 is no surprise, it's all over stuff. That's on the algebra worksheet. Algebra worksheet, right, okay, thank you. Thank you, chat. Oh, and people in chat are trying to work out whether other people have submitted an application. Maybe that's the thing that causes your UCAS ID. I would be surprised if we had any way of verifying them before people have applied. I'd also be a bit surprised. I'm not that surprised if we were verifying them on the go. I should speculate less about the admin that my colleagues are doing. Sorry if any of you are watching. Although maybe join in the Slido chat. We have a big team of people working in the Central University who are looking after admissions test registration, and they're doing a great job. Okay. How much consideration would be given for an exceptionally good or bad personal statement? I don't think I've ever seen an exceptionally bad personal statement. I'm not really sure what that would be. I think it would have to say, I don't like maths, and then not follow that with, I love maths. I don't know. I'm joking a bit, but I can't really think of any case where we've decided not to shortlist someone because of their personal statement. It would have to be really bad. And on the other end, exceptionally good. I kind of still want to see maths, don't I? Personal statement, exceptionally good. I still also don't really know what that means. Presumably, you talk a lot about how you have solved lots of maths problems. You're enjoying solving maths problems, looking forward to university. That's sort of nice. Give some experience, but so what would an exceptionally good personal statement start? I don't just like maths. I love maths because I am Andrew Wiles. That would be a good start, wouldn't it? If Andrew Wiles wants to apply, let us know in Slido if you're watching, Andrew. I don't think Professor Andrew Wiles is going to watch the live stream, I'm afraid. Right. Are the archived papers from before 2007? Oh, well done for finding them. I don't publicise them because I don't think they're that useful. It's up to you. If you've got hold of some very old MAT admissions test papers, or whatever it was called before 2007, then go for it. But don't ask me for solutions. Okay. Right. Okay. We are on 20. I'm losing track of years. 2012 now, I think. I did circle a multiple choice question, didn't I? Yes, I put J on. Once again, I want to look at J because I quite like this question, right? I foreshadowed this by talking about angles subtended by a chord, and excuse me, I'm just going to zoom in a little bit just to get it to. Yes, there we go. And then it pops into better resolution. As we've said before, is this thing where the paper I'm using, you have to hold it really close to your face for it to get into vision. I have to zoom in. This question is written in radians, so we are going to slightly ignore options involving radians. We're just going to do the question. We're going to go for it. What's the largest possible area of this region? And the region is made of, I would say, it's made of a triangle and a bit of a circle. Oh, I should have revised the names of the bits of the circle. And two different Andrew Wileses have simultaneously joined Slido just on cue. One of them's worked out how to set their username. Good to have you, Professor Andrew Wiles. Nice to see you, just in case. I would say this is a triangle plus a bit of a circle like that. Is that a segment? I learn this once a year for the purposes of doing the circle thing. So I guess the question for us now is, given that angle theta, can we say anything about the area? I want to say something about the area. I mean, maybe not in general, but we want the largest possible area. So there's some sense that the picture is incomplete, that there's some freedom in the picture. And I mean, I suppose, of course there is, we can rotate the picture. But maybe there's other freedom. I suppose I don't know where Q and R are, except that there's this angle theta on the left. So we've got this set up with certainly a bit of freedom about what this picture really is, and we're asked to maximize the area of that region. So for example, can I make it the whole circle? Probably not. And the circle's got radius 1, so not as big as pi then. There's some limit. What is it? Is it the word segment? Or it is a segment, isn't a segment? Is it sector for the pizza-shaped one? Segment for the... Trying to cut a circle in half and I missed one? Maybe it's that. Why can't I move R and Q closer to P to make the shaded area very close to the entire circle? And you can, but now you're talking about a different value of theta. So you have some freedom to do things like that, to move R and Q around, but you might or might not be talking about a single fixed value of theta. These are all, if you think that theta is a fixed number at the start of the question, then these are all expressions involving that fixed number. And if you think theta is an unknown, then it can vary, and these are all functions of theta. That's kind of a philosophical difference. But to answer this question, what happens if R and Q get really close to P? Then, well, two things. One, theta gets very large, and two, I know that you are not considering theta to be a fixed quantity. That's how I'd like to think about it anyway, but sort of fixed quantities or something. Sector for pizza, chord creates two segments, thank you. Very educational today, I'm learning so much. Would the angle PRQ be theta as well? No, I don't think so. But I think you'd have to convince me. If you think that triangle is an isosceles triangle, I'll need some convincing. I know this fact about angles subtended by a chord, which makes me... there's something I want to do with the point P. So we've thought about moving Q and R a little bit. If we move Q and R, that changes the region, but also changes theta. So sort of, oh gosh, it changes both at different rates, at different ways, and like in that other question, if you can keep something fixed, then that can help you explore all of the possibilities. Back in that question with x and y, we were keeping xy fixed by moving along that curve. keeping x, y fixed meant that instead of exploring x and y space simultaneously, all the possibilities for values of x and y, instead of exploring all of that, I could just explore along a line, kind of lower dimension, if you like, for what I'm exploring, and that's a good idea because it's less to think about. So here there's quite a lot to think about because there's 3 points. So moving Q and R changes both the area and the value of theta. That's quite hard to think about if I'm trying to maximize this for any given value of theta as a function of theta, trying to maximize something. Yeah, I suppose readdressing the question again is all the options are values of theta. So maybe I can make overall, maximizing it over theta as well, I can make this very close to pi by getting almost all the circle. But the question seems to be, based on the options, to think about this in terms of theta. So now I'm thinking about fixed theta. Any suggestions in chat? I think not yet. I'd like chat to join in a little bit. I think up to you. 6:30. I'm not out of steam. I'm almost out of increasingly cold tea, but here we are. Are the 4-mark questions in the new multiple choice format comparable in difficulty to the old MAT multiple choice questions? Are the 2 and 3-mark questions designed to be easier? The 2 and 3-mark questions are designed to be easier than the 4-mark questions. That is not a guarantee. Judging difficulty of questions is difficult, but we are trying to give more marks for questions that we think deserve more marks, where you deserve more credit for getting the right answer. I suppose those things are subtly different. Yeah, okay, sorry, chat's joining in. Good. And I'm not commenting on whether the questions are harder or easier than past questions, because one, I'm not here to give you information about the test that isn't in the test, and two, I don't think it's an important thing to lose sleep over. Right, okay. Your aim is to do the questions, whatever they are, and you find out the difficulty of the questions by reading the questions and thinking about the questions on the day, and not in advance. Sorry. Yeah, okay. I'm going to interpret the "okay, thank you very much" chat message as someone saying that it's okay for me to stop doing difficulty. Sorry, sorry if I'm getting grumpy on that. I think I've been asked a few times, and I'm sometimes grumpy, and I regret that because it is a thing. I understand why people are thinking about it. I'm trying to be positive and say why we shouldn't lose sleep. As requested in chat, I have joined everything to the center. I would like a next step or something. Bliss in chat knows, let's put it on screen, Bliss in chat knows a circle theorem to say that this angle at the center is 2 theta. So they're off to a great start because they can tell me about the area of this triangle in here or that region over there. Segment, yes, they're going to tell me about the segment, aren't they? They're going to say something clever about 2 theta being the proportion of 2 pi for the circle, or 360 degrees if we're using degrees. So they're going to tell me something about that. The options are all written in terms of radians, but yeah, okay. So this is a good way of getting the information about that segment. How do you let yourself explore the question without getting too stuck on one method? I have developed over time a sense of whether I am getting anywhere, and that's quite hard because this is stupid, but the 2 things you want to avoid are giving up on something that was just about to work, and the other one that you want to avoid is never finding the fast way to do a question. So I've got quite good at knowing when to, if I'm trying to integrate 2 to the x squared, which we saw earlier, I can try a little bit, I suppose, but I run out of ideas pretty fast. And if I try and do something involving like, oh, maybe I could use the trapezium rule or add up lots of numbers, then maybe I remember that this is way too much work and not using syllabus things, so I can sort of abandon that. But when I'm listing all those values of f earlier on, and they're mostly 1s and -1s, I don't know if I'm going to keep listing. I sort of know that I could keep listing out to 100. I could never work out what's going on, but work out all the values for the first 100 numbers. So I sort of know that there's light at the end of the tunnel there that motivates me a little bit to keep going, and in fact keep going, hoping that I spot something along the way. But it's a little bit like, I don't know, playing I Spy or something, right? You got to look around to see what's there, but also see the things that you're looking at. I thought that analogy would sound really clever, but it just sounds really stupid, doesn't it? Sorry. You've got to. The bit of that I liked was not the I Spy framing, but the part where you see the things that you're looking at. So you're getting all these ones and minus ones, and then you think the idea, maybe this is always 1 or minus 1. You notice that it's always 1s and minus 1s, rather than just blindly calculating like a robot might do. I get how to find the area region for a given arrangement of Q and R, but how do I spot where it's maximized? Well, Bliss in chat was telling me about how to calculate the area of, I'm just going to shade in green and then I'm going to erase it, but calculate the area of this triangle and this bit of the circle over here. But we have a question, which is, what's the area of this leftover bit? Maybe if I include Bliss's triangle in here as well, that's the area of the triangle PQR, where, here's the punchline, I think. If you move P around, then you have an angle subtended by a fixed chord, QR. And that means that the angle stays the same. So wherever you put P moving this around, that keeps theta the same. So in some sense, that's a fact from GCSE circle theorems or equivalent. But on the other hand, it's something to do with trying to find a way to isolate the two things that are changing. So as you move P, Q, and R around, oh gosh, theta changes and the area changes. But if I just move P, then theta stays the same and the area changes. So I can maximize it by moving P wherever I like. That keeps theta fixed, and it explores all the possibilities for that value of theta. In fact, up to rotations, but whatever. So it explores all the possibilities for that value of theta, and I'll choose the one where it's maximized by putting P right. So I think about this as the base of the triangle. I want a nice tall triangle. This kind of perpendicular height going upwards. So I want it to be right above the point that's. I want these sides to be the same length. I want isosceles triangles. I want this to be really far away, above like the opposite point from here in the center and over there to P. That's where I want to put it. So I'm trying to think about other ways to say that, other ways to describe that this is opposite the middle of that angle. Opposite the midpoint of QR, that seems like a middle of angle didn't sound right. So opposite the middle of QR would be where I put P to maximize the perpendicular height of the triangle with base QR. And moving P like that fixes theta, so we've got, out of all of the places where we could put P and Q and R, we have to put Q and R that far apart in order to get that angle of theta in the arc. We could rotate the picture for Q and R, but we have to put them that far apart. That's not obvious when you first read the question, that for a fixed value of theta, that fixes the length QR. It's not obvious at all, right? So separate question, rephrase it. Quick rephrase. If you have a circle and you have a point P and you shine a torch with angle theta, you shine that out from the point P in some sort of cone of light. Oh, I'm behind chat. You shine that out in some cone of light to make points Q and R. You point the torch in different directions to see these different points Q and R as you point the torch in different directions. The distance QR is fixed. That's not obvious. And that's the kind of opposite way round of this circle theorem about having a fixed angle above a chord. It's not an obvious fact. I think maybe it is. Maybe if you've thought about your circle theorems quite a lot, then maybe that sort of fact becomes obvious, that there's this relationship between theta and length for a chord subtended by an angle subtended by a chord, or a chord created by an angle, whichever one came first. How did I know theta was fixed? Well, to be honest, I thought about changing theta. I thought, aha, they meet an angle theta and then I can change it. But then I realized that if I'm allowed to change theta, I can make it really large. That's not today, is it? Because today I'd forgotten all of that until Vikram in chat asked me that question about making it close to theta, close to pi. I think it's true the first time I saw this that I was confused and thought maybe we could change theta as well, but then I wouldn't get values of theta. Also, it's a bit weird. Like if it's If it's not a fixed value of theta, then why have they called it out in the question? If it's not a fixed value of theta, then why is it labelled? Like, wouldn't it just say PQR is a triangle? Why would they name one of the corners? I don't know. That's not a real reason. That's just it'd be a weird way to describe the setup if theta wasn't a fixed quantity. For me, by the way, I think theta is a fixed quantity. If you want to think of it, we have a parameter that we're varying and get a function. Can you create video solutions for the papers you haven't done yet, even just a compilation from a live stream? That is harder than I thought. Sorry, I haven't done that. I'm going to say yet, but I'm not optimistic that I'll catch up with past papers this year. Sorry. And we were doing really well. I got up to 2016. It takes an alarming amount of time to do a clean take where I give a good answer to a math question on video. And if I chop up the live streams like this, then, well, there's lots of chat like we're having now. I can't remember the answer to this question. Let's try and work it out really quickly. I think if it's theta up here, no, do I want to do this? I sort of think it might be. It's feeling like A because it's theta over 2. No, maybe I don't want to do this. I've got lots of 1s in here, and thetas. I think I'll leave it as an exercise. So you've got lots of 1s. You've got an angle of theta, and you also include that bit of the circle. There's a rotated version of the picture. That seems like an exercise. It's all in radians, and I don't want to distract people too much by talking about radians. Cool. Okay, that's a short question. Let's do a long question. We could do the cubic one. There's a cubic over here if you want an actual question about a cubic we haven't looked at before. Or we could do a question like underneath. I can think there's some hat logic. Let's have a quick look down here. What have we got? Hat logic. Oh, we've got this game for question 7, which we can talk about. It's got some recursion, I think, or game theory, strategy. Not serious game theory. Don't panic. Colours of hats on expert. This is the one where they're well-known expert logicians. I love that phrase. We've got this question about moving around and drawing a funny picture. And we've got another circle balancing on a parabola. Question 3 that year, have we had a look? Oh yeah, it was like the cubic. Right, what would you like for just 10-15 minutes at the end here, I think. It does feel easier. I also moved away from that question because I thought I was about to do some sort of double angle thing involving theta over 2. And I think double angle was not on the syllabus that year. But it was a long time ago, so I'm not certain. Double angle formula is not on the syllabus this year in 2025. Maybe while you're voting, I'm going to scribble some. Have we finished this calculation? I didn't finish, did I? Maybe I should finish this calculation. So 2 theta, and then am I supposed to do it in radians? It feels a bit wrong to do it in radians. Like that's 180 minus theta. I'm in degrees now. Using that angle at the centre as 2 theta, so that's 180 minus theta. My aim of finding that angle is that I know 2 sides of that triangle, so I'm going to write down half 1 squared sine of that angle now that I found it. But actually I want 2 of those plus whatever was going on over here, 2 theta divided by 360 degrees of the circle for the green region. I remember it was green, of that much of a circle. Oh, sorry, I just shook the screen really badly. Really amazing. Okay, right, good. Okay. But actually the options are all in radians, so what have I done? Also, I want to simplify this sine of 180 minus, of course. That should be sine theta. So it looks like I've got something like sine theta, and then if that's a 2 pi instead, theta as well. So I think I've got B. Do I believe this? So if theta is very small, this is tiny, because my solution is that you have a very small sliver and a little bit of area. That seems reasonable. If theta is large, like about pi, if theta is about pi, then you get pi, oh, pi plus some stuff. Oh, it's slightly smaller than pi though. Oh, that's fun. That's fun. This almost looks like it might be larger than pi if theta is about pi, but it's not, it's smaller. So this is a proof that This is actually a proof, I think, that theta plus sine theta is less than pi for all theta in radians. Maybe I wouldn't have guessed that fact. It looks like it might be about pi when this is about 0 and this is about pi. Positive quantity when it's close to pi, close to 180 degrees. Gosh, none of that made any sense if you don't like radians, or if you haven't met radians. I'm really sorry for that. That's the thing about looking at old questions. Occasionally they're in radians. Question 4 is winning the vote, so I think we're going to have 5 to 10 minutes of looking at question 4. It's balancing circles on parabolas again. Chat. I think you made me do one of these last time. Should it be less than or equal to pi? Yes, because if theta is equal to pi, that expression was equal to pi. I am going to go back and fix it. Thank you, chat. I've lost it. It's gone somewhere. And now I've also lost the question that we're doing. Oh my goodness, sorry for all the zooming around. I've gone back to the wrong year. There we go. If in doubt, zoom out. If in doubt, zoom out. 4, okay. No chat for more space. How long would you sit with a multiple choice question before you move on if you're stuck? Honestly, like about... I have a very short attention span, so about 5 minutes maybe. I don't know, 5 minutes feels like a lifetime to me. Thinking about the same question. If it's multiple choice. That's not exam advice. I interpreted that as a personal question, sorry. Right, other people in chat, welcome to recommend how long they spend thinking about questions. Especially if you have a functional attention span. Right, here we are, not looking at chat for the attention span reasons. Here's a diagram with a parabola. It is everyone's favourite parabola, y equals x squared, and a circle with centre 0, 2. And it's just resting on the parabola. Hang on, didn't we do this at some point on a worksheet as well? Has chat voted for a question on a worksheet? Am I being pranked? No, I'm going to do it anyway. Maybe not everyone saw that on the worksheet. So let x, y be a point on the parabola. Show that the gradient of the line joining this point to the centre of the circle. So to start off with, there's nothing about points A and B. They're just not in here. So x, y, and we're asked for this distance. No, we're asked for the gradient of that line. So rise over the run or something, we've got this change of y values, which is x squared on the parabola, and it is 2 for the centre of the circle, and we've got this change in x values. Okay, and then coordinates of B, that happens precisely when the gradient of the parabola is at right there. The gradient of the parabola multiplies with the gradient of that line to give -1, because they should be at right angles, because for a circle the radius is at right angles to the tangent, and they are tangential to each other. That means that they have a shared tangent. That you could draw a single line, and indeed I have tried to. You could draw a single line that's tangent to both, and then it'll be tangent to the parabola. Good news, we know about tangents to the parabola, and it'll be tangent to the circle. Good news, we know about tangents to the circle. So then we've got strong feelings about how this should be something like x squared minus 2 over x multiplied by the gradient of the parabola should be exactly -1. I hope I've got that all the right way up. I think I have got that all the right way up to give the value of x squared, and of course it's on the parabola as well, so and that value of x squared appears here. Okay, area of a circle. I look at this, I'm in fast mode now. Sector of the circle enclosed by the radius to A, the minor arc AB, that means the shorter of the two, so around this side, and the radius to B is equal to, and then there's some horrible expression which I think is using radians, and it's using this cos to the -1 notation, which you might or might not have seen for inverse cosine. You give it a value between -1 and 1, and it returns an angle that has cosine equal to that number you gave the function. It undoes cosine. It's usually defined to return an angle that is between 0 and 180 degrees, where cosine takes its full range of values, doesn't it? Anyway, this function I reckon is going to return an answer in radians, because this is from an old math paper where everything used radians. That's fine, of course, but if it was written these days, it would have an extra factor of, oh gosh, pi over 180 or something. Anyway, let's evaluate. Oh well, we know where everything is, don't we? We know the point A, we know the point B, we know the point here is 0, 2. So we know all the lengths. We know lengths in, and then there's a triangle. We know the lengths in this triangle. We would like the angle. Why do we want the angle? Well, because we're trying to find the area of the sector, and that's the only thing that depends on is the angle at the centre, really. So we can find that, we're done. Are we expecting it to be nice? No, because the answer is printed here, and it involves the square root of 7. So that motivates me that if I'm doing some work now and it's horrible, then so long as it's horrible and involves 7, then I'll be okay. Right, for example, I need to find, I'm not going to do all of this bit I think, but to find the distance along this side, it's an isosceles triangle, so I'm halfway there once I've done that. I need to do things like, oh, why have I split that out? Okay, I need to do things like the difference here is 1/2 for the y coordinates, and the difference in the x coordinates is √3 over √2. So along here, I have length for this side is Pythagoras hypotenuse stuff. Oh my goodness, this looks like a mess, but I see a factor of 14 over 4, which is √7 over 2, so it's a mess, but it involves √7, so I'm vaguely happy. I also need to find out this length, which seems easier. I believe it might be twice square root 3 over 2, and then we've got some cosine rule perhaps. Combining together so many different things, right? Like we're looking at parabolas, we're differentiating, there's some calculus, there's the idea about lines being at right angles if their gradients multiplies -1, there's tangents to a circle, there's cosine rule for triangles, we've got Pythagoras in there, we've got everything all at once. Like it should be. Good, okay. And then we are asked these facts. So for the last parts, we have a circle with centre 0a, which varies the number 2, I suppose, resting on the parabola. And we're asked for the range of values of a, for which they touch at 2 distinct points. So what I think I want to do is to change the number 2 in here to a, and to redo some of the work. I think that's my strategy here. Let's redo some of the work to say, can we solve this equation, right? So if I put in a different value of a, but try and repeat all the maths, well, this 2 comes from an a that was in there somewhere for a gradient, but that 2 on the right comes from differentiating the parabola. So you get the kind of nuance, don't you, that we want this to be the case in general. Well, I'm off the bottom of the screen. Over x, but then this remains at 2x over here, that's still a 2. We still want it to be -1 because we still want this idea that it touches, and that's a quadratic, I think, which might or might not have some solutions. So separately I want to think about 0, but also I have a quadratic on the screen, which might or might not have solutions. That seems good enough, that I might or might not have points that do this thing that we were doing before. Then later on, previously, we were thinking about distances. When we started to get into this part, I had to calculate a distance. Down here, we're also supposed to calculate a distance. This pulls up the vertex of the parabola, which I could rewrite as saying where x equals 0. X equals 0 is clearly important for this question because we're divided by x over there. Oh, off the bottom of the screen again. Good, okay. Would a question like this be on our test? Oh, goodness me, no. Not for the long question, right? Because how would you draw the diagrams or talk about the triangles or explain which lengths you were calculating? Or type the square roots. So, goodness me, no. Right. Off-topic question. Is there anything you would especially recommend seeing regarding maths at tomorrow's open day? So here at the maths department, we're running maths talks at the department. You can come along. There's a talk called Maths at Oxford, which is me presenting various bullet points from the prospectus, but with some added showmanship, I suppose, to put it in commercial terms. So I'll be excitedly reading bits of the prospectus and telling you about maths. More importantly, there is a sample lecture, a kind of taster lecture, kind of showing you some maths. Not quite in the style of a lecture here at Oxford, but just we've got a maths tutor to show you some maths. So if you're along tomorrow morning in the maths department, you can choose one or either or both or neither of those things to go to. I think some people are going to avoid the maths department entirely and just use their day to look around colleges. Most of the colleges are running a meet the tutor session or something like that with a mathematician. So almost wherever you go, you will find some maths. But I'd recommend in particular the taster lecture that we're running here in the maths department, if you can make it over in the morning, or maths wherever you can find it in the colleges. And if you want to come to my talk about why you should study maths at Oxford, then you're welcome to do that, and I'll see you tomorrow. Right, good. How long should you spend on multiple choice question before moving on if you're stuck? I look at them for I can't tell you when to stop, right? In some sense, you might never give up. Right, okay, good. I think that is where I'm going to call it. I'm going to leave slightly early today. Sorry about that. And next week, circumstances outside of our control, live stream will be on the Friday instead of the Thursday. So we're on Friday the 26th of September. So same YouTube channel, same place. If you're subscribed to the channel, you will get you'll be in the right place for it. And maybe this gives you an extra day to try the 2013 MAT paper ahead of time. But I'm almost always live on Thursdays. Next week it's going to be Friday. But I really do need to run. What do I look for in a reference? UCAS reference guidance is on the UCAS website. Good luck with your UCAS reference. Some of these questions I can't answer, right? Good, okay. We're going to leave it there, I think. Thank you very much for joining with the questions. Thanks for your suggestions. I hope you're having a good time trying some math questions. I will be back next week in Thinks Hard 190 hours. I'll see you in about 190 hours for another episode of the Oxford MAT Livestream. Until then, have a nice evening, have a nice weekend. See you next week. Oh, I forgot to edit this. Right, hang on, there we go. There we go. Back next Friday. See ya.